Okay, so this is part 3. Explain the observed instability observed in number 2 via a von Neumann stability analysis and why a limit of r is equal to 0.5 occurs. Okay, so we have 0.55 right here. You get these absolutely huge, outrageous numbers, right? In the graph. So let's change it to 5. Okay, that looks normal. Let's change it to 0, 1. Because that's kind of after it, right? Oh my goodness. Oh my goodness. So as you can see, there's a little bit of oscillation here with all these little gaps and everything. So what happens when you have the r is equal to anything over 0.5, you get too large of a step and then it overcompensates, and that's how you get the oscillation. So wait, what happens here? I guess nothing. I'm just playing around with it because I'm curious. How many zeros does it take? Made 2 zeros. Let's see what happens. Oh. Oh, okay. It's still fine. So now we're going to do the next part, which is the von Neumann stability analysis. I really wish there was a way to pause these, but I am back and I am ready to talk about the instability seen when our R value was greater than 0.5, as you can see on this right here, when we had the oscillations when it was like 0.55, or here, I'm just actually say 0.52, right? Yeah, you see the oscillations and whatnot that are shown in this little graph that doesn't want to cooperate. I'm not really sure why. Okay, that's fine. So we're going to open up OneNote again and then go back to OBS. So I'm going to be writing on my iPad once again. So what we're going to do is, okay, so I wrote out the Fourier series before I started recording, and so this is what we're going to use, and we're going to be plugging that into our equation that we got earlier. So if I go to my work and then I go to, let's see where I put it earlier. Would it be here? Let me look on my iPad. Yes, it is this one, but I have to zoom out or something. Yes, I had to go down. Okay, so we're going to be using that equation right there. I might just work on here, actually, now that I think about it. I'm just going to make a pink line right there. Am I on the right page? Yeah, I am. Okay, so what we're going to do is we're going to, like, move down just a little bit, right? And I'm going to go into text mode, zoom in, and I'm also going to go to back to OBS recording so I can see what I'm doing, and move my wonderful little face into the corner even more. Okay, so for your series, so you have that. Let me change the color back to white, which is black on my screen because my iPad's in dark mode. Okay, so you have the T and you have x and t. Those are the variables that you're using. And then, so it's a series, so you're going to have x from negative infinity to infinity. That was an ugly equal sign. I don't even know what happened there. Forgive me. Okay, so then we're going to have this constant right here. You have e to the negative imaginary number k, change in x, e to the another imaginary k, and then change in x, but positive. Okay, so what we're going to do is we're going to take my cat's sleeping, it's nice. Okay, so this right here, and this right here, and we're gonna take stuff from the Fourier series and put it into that. So is my stuff showing up on the screen? Just a little delayed. Okay, it's fine. J plus, and so at the next position, we're going to have t to the j. Instead of saying plus 1, we're going to say e to the I, k, change in x. And the reason why my handwriting looks a little bit more legible is because I'm holding my arm so it doesn't shake. Okay, so then tj minus 1, and then we have to the n at that time n. So then we have tj to the n, we have the e. Ooh, that's not an e. I don't even know what that is. It looks like a theta. E to the negative imaginary number k, change in x. Right? So then what we're going to do is we're going to plug that sucker back in to our equation up here. Can I draw a star right there? Draw a star on this side. My pen's not working. Oh, it turned off. Star. Okay, so what we're going to do is we're going to say t, and then j, n plus 1. That looks like, I don't even know what that looks like. It's fine. N plus 1 is equal to, why wasn't there a j here? Does it not need a j? Interesting. It's fine. Where was I? J n plus 1. Oh, I'm plugging back into. So then t n, then plus r, and so then you're going to plug in that t to the j to the n, e to the I, k, change in x. Oh, that's not an x. What did I do? X. And then minus the 2 tj to the n, and then plus the tj n e, and then we have to go into text mode and move my screen over because it's so tiny. E to the negative. I'm going to make this look as legible as possible. Don't ink select. Negative I, k, change in x. Right? And then we're going to put our bracket. So, let me zoom out and look at this sucker. It is horrifying, yes. But I see that we have this a common factor in here, and it is that tj to the n, right? So I'm gonna pull that out, tj to the n plus 1. You know what? I'm gonna zoom in again so I can write a little better. Text mode, zoom in. Right, okay, so T, J, oh, you can't even see what I'm doing. I feel silly. Don't you feel silly? Don't you feel How can I zoom out? That is a good question. How do I zoom out? It does not say. I feel like I'm just gonna have to cut a lot of the figuring stuff out. Okay, so n plus 1 is equal to t j n plus r. Then, okay, so we have a tj. Ew! It's fine. In. I'm just gonna put r. Okay, so it's e to the ik change in x minus 2. I'm gonna go to text mode so I can move over. And we're gonna wait here. Let me zoom in a little bit so I can write better. And then we go to plus, and then we have the e to the negative I k, and then change in x, if I remember correctly. What the heck? It's fine. So then we're like, okay, well, what am I supposed to do with this? Well, we use Euler's equation because that's what we do. And then so let's see. Okay, so e to the ik. Can't see that on the screen, so I'm gonna change my position on here so that you can see. I want you to be able to see what I'm doing. Okay. Change in x. Yep, we're gonna okay, we're gonna zoom in too. So let's zoom in, right? And we're gonna say e to the ik change in x. My k's look like h's. That's okay, kind of. Okay, so then that is equal to, and it's a cosine of kx, I believe. And then it's going to be like plus I sine of kx, because they're using kx still. Okay, you can see that. Okay, so we're going to use this Euler's part of the equation. We're going to plug that sucker into what we have, right? Okay, so what we have is, okay, so I'm going to pause. With our algebra knowledge, right, that we have obtained from our many years in our education, we're going to take this Euler's equation. We're going to put that sucker into our equation. So how do we put that in? Well, we know that we have, like, here, you can't even see it anymore. Let me look to see what I have here. We have these e to the i's with the k's and the change in position. And we want to get rid of that because it's ugly and because algebra, right? So we have cosine. Let me write a little bit smaller than that so I don't have to move so much. Okay, back to this. So we have cosine of kx. Oh, that k looks better. Yeah. Okay, so kx is equal to, and then we have e to the I k change in x, right? And then we also have plus e to the I k change in position, right? Okay, so then what we're going to do with that is we're going to say, oh, okay, so that means we have 2 cosine. So we're going to be like, okay, so let me write our new equation with this new knowledge that we have here. TJ. I made an oopsie. Oh, I'm going to have to erase the whole n. I just want to formally apologize again. Okay, so then we have that. Let's see. Let me look at my equation up here to make sure I'm doing this right. Okay. Okay. So you have cosine, and we have a -2. Then we have this. Oh, we can pull that TJ in out as well because it's being multiplied. So it'd be like a +1. All right, so we have the, oh, here, let me zoom in again. TJN. So then we'd have a 1 plus the r that's on the outside of that equation. And then we have our, 2 cosine, because you have the e's right there. So then 2 cosine, it's looking a little graffiti-like, of kx. Yeah, and then you like -2 still from earlier. Let me move my screen over. All right. That was terrible. -2. Okay. Well, now what? Well, okay, so I'm going to kind of like pretty bracket this. Oh, I'm getting so good at this. Okay, so I'm going to move down. And so what we have to do here now is going to write the absolute value of this. Oh, I'm still in text mode. Yeah, you can see everything on there. The absolute value of this 1 plus r. We got this parenthesis. Hey, it's not a parenthesis, it's actually a bracket. That's fine. It's fine, it's a parenthesis right now. 2 cosine of this kx. Another. Sounds like somebody got hurt. And then -2. Then you have your other thing. Okay. Did I forget a parenthesis earlier? That's a parenthesis, bracket there. No, it's fine. Okay. So, and then you're always going to have this less to 1. Cleo chill. Okay. So, okay, I was foolish in my endeavor to make this a better absolute value sign. It's okay. So we also have to recognize that with this right here, right? This can only be between -1 and 1 with it being cosine, right? So then our next part is to say like, okay, so -1, it's less than r, and then we're gonna say, because it has that -2 in there, oh no. No. Okay, so I realized that I made a mistake, making another recording. Is my pen all the way? Okay, I'm gonna cut that out, I think. Okay, so our next part is to realize, okay, well, we have a -2 here. We have less than r, then we still have that 2 cosine of kx, right? And we have the minus 2 is less than 0. Because you take that 1 that's going to be less than, and you just subtract to the other side, right? Yes. No, you don't do that. You change it into one of those kinds of inequalities that's like less than and then less than on both sides, right? Okay, next part of this is I have to recognize that we have to go to -1 is less than r cosine of kx minus 1. My cat sees something. What's wrong? Okay, it's fine. It's 0, right? And this is always going to be between, or here. This is going to always be somewhere between -1 and 1, right? And so then our next part is going to be -1 is less than -2r is less than 0. And then we divide by 2 on both sides. And my pen turned off again. I love it here. -2 on both sides, right? When you divide by -2, you switch the signs of the inequality. So then you do 0 is less than, instead of being, greater. 0 is less than, r is less than, then -1 divided by -2 is 1/2. And so your r value has to be somewhere between the 0 and 1/2. Now that I think about it, I'm gonna see what happens if you put a negative number in there. But I'm guessing there's probably something with the programming that prevents negative numbers from impacting it. But yeah, that's